Hello friends, good evening. I am Dr. Kaustubh and I welcome you to UPSC Guides Prelims PYQ discussion series. In this series, I'll be discussing the PYQs of geography to identify the key concepts, the patterns, and whatever the concepts are, along with the takeaways for solving prelims PYQs. This will help you refine your strategy and improve your accuracy in this most important qualifying examination. Hello friends, good evening. I'm Dr. Kaustubh from UPSC Guide and today we are discussing the previous year questions of geography, and this section is focused on climatology part 2. Let us look at the questions. First, consider the following statements. In the tropical zone, the western sections of the oceans are warmer than the eastern sections owing to influence of trade winds. Now, this is asking you about the temperature of the ocean water, and it is saying that in the tropical zone, in the tropics, the western section is warmer than eastern section of the oceans. And why? Because of the influence of trade winds. This is correct. If you look at, say, Atlantic Ocean, in the tropical belt, you have trade winds broadly moving from east towards the west. Now, when you are moving from east to west, trade winds, they are going to carry the warm water of the surface of the ocean towards the west. This accumulates the warm water towards the west, resulting into warmer ocean towards the west than eastern. So, this is correct. In the temperate zone, westerlies make eastern sections of oceans warmer than the western section. Now, in the temperate belt, it is saying that eastern section is warmer than the western section. Which of the statements given above are correct? Answer is C, both 1 and 2. See, what we have seen is this ocean water and the ocean currents, you must have heard about them. These ocean currents are driven majorly by the planetary winds. So in the tropical belt, the trade winds move from east to west. Beyond the subtropical high pressure belt, the westerlies move from west towards the east. Now in this context, you will have warm water from the surface being accumulated in the western section of tropical ocean. In the eastern section, beyond the tropics, you will have warm water accumulating towards the west because of the action of westerlies. So both statements 1 and 2 are correct. Statement 1, tropical zone, in the tropics, trade winds blow from east to west, push warm water, which is surface water. In Pacific, you have this example which are given, El Nino and La Nina. Now, in the temperate zone, westerlies blow from east to west. They carry warm ocean currents from tropics to the eastern side, making eastern parts warmer than the western part. Example is Gulf Stream, North Atlantic Drift, Kuroshio current, and so on. So, option C is correct. Both statements are correct because they explain the global wind and current patterns. Trade winds warm the western tropical ocean, westerlies warm the eastern temperate ocean. So, answer is C. This is also the reason why the western coast of Scandinavia, Norway, it doesn't freeze during even harsh winters. The warm water carried from the Gulf Stream and North Atlantic Drift makes that eastern portion warm. So when you talk about the tropics, western section of the ocean would be warmer. Beyond the subtropical high pressure belt, the eastern section would be warmer because of the impact of westerlies. Okay, let us look at the next question. Consider the following statements. High clouds primarily reflect solar radiation and cool the surface of the earth. Low clouds have a high absorption of infrared radiation emanating from the earth's surface and thus cause warming effect. Now, in this question, there is a discussion on high clouds versus low clouds. Now, what are high clouds? These are the clouds which are like, for example, cirrus clouds, C-I-R-R-U-S. These are the clouds which are present in at a distance of nearly, say, 15 to 20 kilometers above the mean sea level, right? Top layer of clouds. And low clouds are the clouds which are like 2 to 5 kilometers from the surface. Now, how do these high and low clouds interact with the electromagnetic radiation coming from the sun, short wave electromagnetic radiation coming from the sun, or the long wave terrestrial radiation coming from the earth? Which of the statements above are correct? A, B, C, D. You have an answer here, which is D, neither 1 nor 2. Why? Because they've interchanged the terms. In this question, the characteristic and the clouds, they are interchanged. So, statement 1, high clouds primarily reflect solar radiation and cool the surface of the earth. This is wrong. High clouds like cirrus clouds, I have mentioned, these are thin and they are wispy, so they don't reflect much, right? Which means they allow most of radiation to pass through them rather than reflecting it. Now, ability to reflect the solar radiation, which is also known as albedo. Albedo is property of reflecting the incident radiation. This albedo is high in thick clouds, not in cirrus high clouds, which are very thin, wispy. So most of the solar radiation will pass through them. They are transparent. Instead of cooling, high clouds trap the outgoing infrared radiation. It is the other way around. They lead to the greenhouse effect. The long wave terrestrial radiation coming from the surface of the earth is trapped by these high clouds and is re-radiated back towards the earth's surface, right? If I have to show you this, this is the surface of the earth, this is the high cloud, right? So this high cloud will allow the solar radiation to pass through, but the terrestrial radiation which is coming from the earth is trapped and is re-radiated back to the surface of the earth. That is why these high clouds do not trap or do not reflect the solar radiation coming from the sun, right? Second, low clouds are more effective at reflecting sunlight and cooling the surface, right? Because low clouds, they are thick. Stratus and cumulus are thick and dense. So these low clouds are thick clouds because of more moisture. So these thick clouds are more effective in having a strong albedo. They reflect the solar radiation prominently, resulting in cooling, right, rather than warming. So option D is correct because both the statements 1 and 2 are wrong. Next, before we move ahead, let me tell you about a new batch, PARIKSHA, which is targeted for prelims. So there is a very nicely framed question papers for prelims. It's a test series which is being brought by UPSC Guide. Admissions are open. This is for 2025. So if you are preparing for 2022-25 attempt, this is something that you should really enroll and get benefit of. There will be detailed discussion on each test that is conducted. Now, with reference to the Earth's atmosphere, which one of the following statements is correct? So now this question is regarding the atmosphere of the Earth. The total amount of insolation received at equator is roughly about 10 times of that received at the poles. See, insolation is what? Incoming solar radiation. Insolation is incoming solar radiation. The question is saying that the total amount of insolation received at equator is 10 times of that poles, right? Incoming solar radiation. Second, infrared rays constitute roughly 2/3 of insolation, right? Infrared, if you take the electromagnetic radiation, the short wave electromagnetic radiation coming from the sun, you can have various spectra. So gamma rays, there is ultraviolet radiation, then there is visible spectrum, then infrared, and then you have those long wave radiation, right? Microwave and radio waves. Now, infrared constitute roughly 2/3, which doesn't seem likely. Infrared waves are largely absorbed by water vapor that is concentrated in lower atmosphere, right? And infrared waves are part of visible spectrum of electromagnetic waves. Now, these are mostly wrong statements. The statement which is correct is C, right? Which of the statements is correct? Answer is C. Infrared waves are largely absorbed by water vapor that is concentrated in lower atmosphere. If you take the proportion of water vapor in the atmosphere, in the first 2 kilometers from the surface, if you go vertically upwards, in the first 2 kilometers, more than 50% of water vapor is present. If you go to first 5 kilometers, more than 90% of water vapor is concentrated. Now, because of this, the water vapor at the lower end, now this water vapor is opaque to infrared radiation. So it absorbs this infrared radiation. So this C is correct. But then total amount of insolation received at equator is 10 times? No. Even at poles, because of the tilt of the earth, if you take beyond tropopause, even at the poles, radiation received is very high. The only point is it is slanting, right? But if you take the poles and the equator, the incoming solar radiation is high at the poles also. So this first statement is wrong. Infrared radiation, 2/3 of insolation, no. Visible spectrum is a major component. And then infrared waves are part of visible, no. Visible spectrum is, this VIBGYOR. All of you have studied this, you know this. VIBGYOR. VIBGYOR के बाद आता है, visible spectrum के बाद आता है infrared. उसके पहले आता है ultraviolet. That is why infrared is not part of your visible spectrum. Clear? So explanation, the total amount of insolation received, this is incorrect. See, equator does receive more insolation than poles. Angle of sunlight and thinner atmospheric layer passes through. However, difference is not as extreme as 10 times. This is exaggeration. Second, 2/3 insolation consists mostly of visible light and short wave radiation. That is why infrared is long wave, right? So infrared is only a small portion. Majority of infrared is actually emitted by Earth's surface. So long wave terrestrial radiation, this is the majority of the infrared radiation that is coming, and this is absorbed by the low clouds. Next, infrared waves are largely absorbed by water vapor. Yes, troposphere infrared emitted by Earth is absorbed by water vapor and other greenhouse gases. It helps retain heat. So this is the greenhouse effect. And lastly, D, infrared waves are not part of visible spectrum. We have spoken about this. Violet to red, right? This statement is incorrect. So only one option is correct. Water vapor absorbs infrared radiation, right? Contributing to atmospheric heating. This process plays a crucial role in energy balance and greenhouse effect, right? Final answer is C. Infrared waves are largely absorbed by water vapor that is concentrated in the lower atmosphere. So answer is C. Next, consider the following statements. Now this is about the soil. Statement 1. Soil in tropical rainforest is rich in nutrients. See, this question is on the topic soil. If you divide soil in various types, right? Equatorial area has different, mountain has different, forest has different soil, desert soil is different, then you have black soil, alluvial soil, and so on. So if you're talking about soil in equatorial rainforest, right, that is the term, tropical rainforest. So if you talk about a soil in tropical rainforest, what is the soil facing? It is facing high temperature and it is facing heavy precipitation. Tropical rainforest has hot and wet type of climate, right? So heavy rainfall and high sunlight, radiation. This both result into, this heavy precipitation results into leaching. So along with the heavy rainfall, the water, the nutrients in the soil get washed away. That is why the soil in tropical rainforest or equatorial rainforest is generally poor. It is not very rich in nutrients. So first statement doesn't seem to be correct. Statement 2, the high temperature and moisture of tropical rainforest cause dead organic matter in the soil to decompose quickly. Which one of the following is correct respect to? So this both statements are correct. 2 is the explanation. You know this pattern. D is correct. Statement 1 is incorrect, but statement 2 is correct. So second statement is correct, but it doesn't explain. The first statement is wrong, as we have explained just. If you go to tropical or equatorial rainforest, the quality of the soils is generally poor. Though there is a dense forest, the quality of soil is generally poor. Now that also explains that why deforestation in these areas should not be done, like say Amazon or Indonesia or even in our northeast or in Sahyadris. Why deforestation should not be done? The moment you do deforestation, the regeneration of forest in this area is very difficult because the soils are leached, they are nutrient deficient, and regeneration of the forest requires a lot of effort and it's not easily possible, right? So statement 1 is incorrect, statement 2 is correct. This high temperature and moisture, the organic material is decomposed very fast because temperature and water both act as catalyst, right, for the chemical decomposition. Statement 1, tropical rainforest soils are actually poor in nutrients, leaching, right? Most nutrients are stored in biomass, not in the soil. When leaves and organic matter fall, they are decomposed easily and absorbed by the plant roots. So rainforest soils tend to be infertile in general and nutrient poor except for thin layers of decomposed organic material on the surface. The second statement, warm temperatures and high humidity accelerate decomposition. There is absolutely no doubt. The temperatures are high, so high temperature acts as a catalyst in a chemical reaction where the decomposition of this humus or organic material takes place. High humidity accelerates the decomposition. Microbes and decomposers break down. Rapid decomposition, so most nutrients do not accumulate there, right? So options D is correct, statement 1 is incorrect and statement 2 is right? So the answer is D. Next, consider the following statements. Again, atmosphere. The atmosphere is heated more by incoming solar radiation than by terrestrial radiation. Again, basic conceptual understanding. ये जो atmosphere है Earth का, the gaseous envelope, which keeps us alive, which maintains a hospitable environment here. This atmosphere is majorly heated by, the statement says, incoming solar radiation than by terrestrial radiation. This is wrong. Most of the components of atmosphere, right? Most of the components of our atmosphere are transparent to the incoming solar radiation. Very small proportion of this incoming solar radiation is actually absorbed by greenhouse gases and water vapor. Whereas, if you talk about the terrestrial radiation, the long wave terrestrial radiation emitted by the earth 24/7, this greenhouse gases and water vapor, the low clouds, all these are nearly opaque. They absorb as well as re-radiate this heat back to the earth. So our atmosphere, the atmosphere of the earth, is majorly heated by the long wave terrestrial radiation, which is emitted from the surface of the earth 24/7, not by the incoming solar radiation. Second, carbon dioxide and other greenhouse gases in atmosphere are good absorbers of long wave radiation, which is true, right? So here, if you take answer D, so answer would be D. Why? Second statement is correct. First statement, as we have discussed, is wrong. That is why answer is D. One is incorrect, but statement 2 is correct. So we are going to see this again. First statement, we have already said that the major cause for heating of atmosphere is not the solar radiation, but the long wave terrestrial radiation. That is why statement 1 is wrong, right? Terrestrial radiation. Solar radiation, short wave, it's more or less transparent, right? The earth absorbs solar energy, warms up and re-emits. Most of the heating happens when greenhouse gases absorb the terrestrial radiation. So the primary source of atmospheric heating is terrestrial radiation, not the solar radiation. This is the first statement, which is incorrect. Second, carbon dioxide and other greenhouse gases are good absorbers of long wave. That is correct, absolutely correct. That the greenhouse effect, carbon dioxide, methane, water vapor and other greenhouse gases absorb long wave infrared radiation emitted by the earth. It is kind of a trap. The heat is trapped and the temperature is maintained, right? So it's a well established scientific fact. So option D is correct, which means statement 1 is wrong and statement 2 is correct. Next question, again about atmosphere. Thickness of the troposphere at the equator is much greater as compared to the poles. Thickness of troposphere at equator is much greater as compared to pole. Now, if you read NCRTs or apply your basic logic, you know that at equator, the air is moving vertically upwards. At equator, the air is moving vertically upwards. Warm air is moving vertically upwards because of insolation. This air, which is moving vertically upwards, it tends to push the tropopause up. Whereas, if you talk about the poles, what happens at the poles? There is descending air. Air descends down. It tends to compress the troposphere. So what do we have? We have the thickness of troposphere is much larger as compared to the thickness of troposphere at poles. So first statement, thickness of troposphere at equator is much greater as compared to pole. It is true. At equator, the thickness of troposphere or the tropopause would lie at a height of nearly say 15 to 16 kilometers in certain cases. Whereas if you go to poles, the thickness of troposphere or the altitude of tropopause is around 6 to 9 kilometers, which is nearly half of it, right? Statement 2, at the equator, heat is transported to great heights by strong convectional currents, which is true, right? So this kind of explains why troposphere has a greater thickness at equator. So answer is A. Both statement 1 and 2 are correct and statement 2 explains statement 1, right? Statement 1, thickness of troposphere at equator is greater. This I've already explained that 16 to 18 kilometers and poles it is around 8 to 10 kilometers only. Greater heating of the equator where vertically rising winds push the tropopause upwards. Lower temperatures, compressed atmosphere at poles. Now statement 2, heat is transported. So that is this intense solar heating that is resulting into convectional currents. And this warm air is rising up, pushing the tropopause up. So expansion of air increases the thickness of troposphere. In contrast, at poles, there is weak convection, less vertical expansion, and there is descending wind, right? Thinner troposphere. Option A is correct, both statements are correct, and statement 2 is a correct explanation for statement 1. So answer here is A. Let us, friends, look at the next question. With reference to water vapor, which of the following statements are correct? Right, water vapor. It is a gas, yeah. The amount of which decreases with altitude. It's a fact that when you consider water vapor into atmosphere, I told you the numbers. If you go from mean sea level vertically upwards, in the first 2 kilometers, you have 50% of water vapor. If you go to first 5 kilometers, you have more than 90% of water vapor, right? So as you go vertically upwards, the proportion of water vapor in the atmosphere goes on decreasing. Its percentage is maximum at the poles. Doubtful. The percentage of water vapor at poles must not be very high. Rather, where there is more evaporation, equator and subtropical high pressure belt, or the tropics overall, should have greater percentage of water vapor. So here, which of the following statements are correct? Answer is A, 1 only. Second is wrong. Percentage of water vapor cannot be maximum at the poles, because at the poles, the temperatures are very low. If the temperature becomes very low, the humidity capacity or the ability of air to hold moisture goes on decreasing. I repeat again, as the temperature goes down, the ability of air to hold moisture also goes down. So water vapor cannot survive much at poles, because it will be easily condensed. Snow, right? It will be easily condensed. As opposed to it, if you come to equator or tropics, because there is high temperature, the air in the tropics has a greater humidity capacity. The ability to hold moisture is very high. So evaporation, because of intense insolation, evaporation is also very high. So there is a lot of water vapor that is coming up from the oceans in the tropics, and this water vapor is present in the atmosphere because the atmosphere has high temperature, allowing it to hold that moisture for a longer period. That is the reason why we have statement 1 is correct and 2 is wrong. Let us look at the explanation again. Gas, amount of which, yes, water vapor is a gas, most abundant near Earth's surface. With altitude, temperature drops and ability of air to hold moisture or vapor decreases. So humidity is highest at lower altitude. Now its percentage is maximum at the poles. No, water vapor is not maximum at poles. It is highest in tropical equatorial belts. The poles are extremely cold, very low evaporation, low atmospheric moisture. Warm tropical areas have high evaporation rates, vapor concentration, right? So rather the polar atmosphere is very dry. So statement 1 is correct, statement 2 is incorrect. Answer is A, 1 only. I hope you have understood the explanation. Now let us go to the next question. Consider the following description. Annual and daily range of temperature is low, right? The annual range of temperature across the year and the diurnal range, daily range of temperature from day to night is low. Precipitation occurs throughout the year, right? So no season, there is no specific rainy season. Throughout the year there is precipitation. Precipitation varies between 50 to 250 centimeters. Now this is a great variation from 50 centimeters to 250 centimeters, right? What is this type of climate? Is it equatorial? Because if you say equatorial, there should not be so much variation, right? Equatorial, the second statement would be true for equatorial. First one, annual and diurnal range of temperature is low, may be applicable, but the third one, 50 to 250, this is not typical of equator. At equator, the precipitation will be heavy. So the variation in precipitation would not be 50 to 250. China type, humid subtropical and marine west coast climate. Now this is a description which fits D, marine west coast climate. Why? Let us see. See, annual and daily range of temperature is low. Marine influences moderate weather variations. Both summer and winter temperatures remain mild. Now, marine west coast means what? This is, if you go to Britain, you have this western margin, warm temperate type of climate. This is the climate that we are talking about. It is the result of onshore westerlies, which bring the temperate cyclones, not tropical. These westerlies bring the temperate cyclones onshore in Britain. So this British type of climate, or warm, temperate, west coast or western margin type of climate. So here the summer is also mild. It rains throughout the year. winter is not very severe because it is not too dry. So onshore westerlies है, so ये जो variation है, if there is no temperate cyclone, the onshore westerlies may give you say 50 to 70 to 80 centimeters of precipitation. If there is a cyclone coming, the precipitation may drastically increase and go to right 200 to 250. Right, that explains the variation. Right, precipitation occurs throughout the year. Yes, frequent cyclonic activity, rainfall year round, moist maritime air mass, steady precipitation. Right, onshore westerlies are there, and marine west coast climate receives moderate to heavy rainfall. Right, generally between 50 to frontal systems. Front मतलब temperate cyclones की बात कर रहे हैं. So frontal systems and orographic effect. Right, equatorial is wrong because equatorial they receive very high precipitation unlike the given range. Daily temperature is low, annual temperature remains high. So range of temperature daily will be low, but between summer and winter, the range of temperature may also be high at equator. Right? China type, it is monsoonal, distinct dry season hota hai China type of climate mein. Right? Wet seasons unlike the year-round precipitation, and humid subtropical, rainfall is seasonal again, monsoonal influence, greater temperature variation than what is described. That is why the correct answer is marine west coast type of climate where there are onshore westerlies throughout the year. These westerlies tend to bring the frontal systems, which means the temperate cyclones which are onshore. So the temperature remains more or less in a moderate range where the summers are also mild, winters are also mild. The range of temperature daily and annual are not very high, and the amount of precipitation because of the frontal or cyclonic activity tend to vary between 50 centimeters to 250 centimeters over a year, right? So this is the answer D. Typical marine west coast climate found in Northwest Europe, Pacific Northwest of North America, Chile, Southeast Australia and New Zealand. Marine west coast type of climate. Clear? Next. With reference to Coriolis force, which of the following statements are correct? Now you've heard about Coriolis. This is a force which results into deflection of winds. Right? In the northern hemisphere, the winds are deflected towards their right. In southern hemisphere, the winds are deflected towards their left. You know that there is no Coriolis at the equator. But as you go towards pole, the curvature of the earth becomes more and more, and this Coriolis goes on increasing towards the pole. So here, with reference to Coriolis, which of the following statements are correct? It increases with increasing wind velocity. Yeah, we can say that if wind velocity is high, the impact of Coriolis can be felt more, right? It is maximum at the poles and is absent at the equator. Absolutely correct. That's what I said, that at equator, the wind is moving vertically upwards and it is relatively flat surface. So Coriolis is generally absent. But as you move towards the poles, the curvature of the earth is geoid in shape. It is pressed at the poles. So the curvature of the earth becomes more and more steeper as you go towards the pole. So the Coriolis impact is higher. And if there is more velocity, the Coriolis, again, the impact of Coriolis on the wind deflection is high, or deviation is high. So answer is C, both 1 and 2. Look at the explanation. Coriolis force is apparent force caused by Earth's rotation, right? To the right in the northern hemisphere and left in southern hemisphere. We have seen this. First statement, it increases with increasing wind velocity. Coriolis force is directly proportional to wind speed. So if the wind is moving with a great velocity, the wind will experience greater impact of Coriolis force. So there will be more deflection to the right in the northern hemisphere and to the left in southern hemisphere. Faster moving winds experience greater deflection. Mathematically, since wind velocity is multiplicative factor, increase in wind speed increases the Coriolis. Second, it is maximum at the poles and is absent at the equator. Coriolis depends on latitude, right? At the poles, Coriolis is maximum. At the equator, Coriolis is absent. That is why hurricanes and cyclones do not form exactly at equator, but slightly away from it, right? So see, all the cyclones, right? Cyclones require Coriolis force, rotational moment of wind. So cyclones are generally absent at the equator. As you move away beyond the ITCZ, you will see that the cyclone formation, the frequency and intensity of cyclone increases beyond the ITCZ, right? So both statements are correct. Coriolis increases with wind velocity and it is strongest at poles, absent at equator. Answer is C, both 1 and 2.